Shengwu, like, wave a thumbs up or something with your avatar. All right, cool. So thank you all for joining us today. We're very honored to be kicking off the tutorial session. I'm going to be speaking jointly with Mohammad Akbarpour and Pyotr Dvorak about redistributive market design. And this is a sort of broad agenda that the two of us have been working on, along with other co-authors, including Shengwu Li and Eric Budish, and that we see sort of as both providing new opportunities for market design in practice and an opportunity for an important sort of practical question, the presence of inequality in society, to feed back into market design. I guess I will abuse my privilege at the start of the tutorial to say, something that I typically say when I give talks on this work, which is that we have put our names in certified random order, but in some Shapley value sense, you should apportion more than 2/3 of the credit to my co-authors, because this agenda could never have happened without either of them, but could certainly have happened without me. So if you add up the marginal sub-coalitions, sort of the Shapley value to the two of them is more than 2/3. But in any event, I'm going to kick us off. So I'm going to frame a market design approach to redistribution. And the overarching high-level question is, how should we design marketplaces in the presence of inequality? So first of all, it's important to make clear what we mean by this. Oh, and also just one point of logistics, which is that because of the way share screen and gather works, I can see my screen, but I can't see the gather room at this moment. So if you have a question or something of the sort, it should, throw it into the chat. It should make a noise, but if we're not acknowledging it, just rush the stage and shout out. So framing assumption is going to be that the designer regulates or controls a single market. And so this is going to be, different from, and we're going to argue complementary to, the standard public finance approach to redistribution, which is, you're a planner who has macroeconomic power. You can set taxation and redistribute. Here we're imagining you're an individual regulator, maybe a housing authority, or the regulator responsible for regulating rideshare, or you're a marketplace organizer. So you run a rideshare company or something of the sort. And so you have vision into and the ability to design policy for a single market, but you don't necessarily have the ability to do sort of full-scale redistributive taxation. And first, just an anecdotal sort of empirical observation is that in these contexts, various forms of market distortions are frequently used, right? So if to address inequality in individual markets, in the housing market, we have both public housing and rent control. These are sort of subsidized goods or goods with prices sort of fixed below the market clearing rate. We have free or subsidized healthcare, lots of in-kind distribution there. Food stamps, same thing, right? Sort of in the United States and in many other places, there's in-kind food aid. Road access is a really interesting example, because this is sort of the dog in the nighttime not barking, right? The typical economist is very in favor of congestion pricing for roads in various forms, right? The idea is that, not only does congestion pricing help ensure that people internalize the externality of the congestion they cause on roads, but because congestion decreases throughput, it can actually be Pareto improving to have congestion pricing. And yet, nevertheless, you frequently see policymakers and sort of groups of individuals being very opposed to congestion pricing on the basis that they sort of want the roads to be freely accessible to all, right? Driving at peak times should not become the province of the wealthy. Which again, it's sort of an argument that sounds strange to an economist, but this is a common argument that's made. And then, of course, there's vaccines, where in the COVID-19 vaccine rollout, as we all experienced in one fashion or another, there was almost every country opted for some form of prioritization rather than just selling vaccines to the highest bidder. So we're going to look at these sort of these policies and ask, are they a good idea? And if so, how should we design them? But let me just quickly, sort of remind everyone, the knee-jerk economics idea is no, or the economics answer is no. These are market distortions, and we generally prefer efficient market clearing. But let me try and convince you that actually these types of distortions might sometimes be a good idea. And then like Mohammad and Piotr are going to sort of go on and develop the story and show sort of how in optimal mechanism design this very much can be the case. But to get there, I want to just start with the standard economic intuition about market clearing pricing. Like, why do we like market clearing pricing? Well, here's supply, here's demand. I was terrible at reading these pictures, so I always have to like belabor it. So like, so the supply curve slopes up. You can think of sort of each point in this line as like a person, and this is their cost of provision. Same thing, demand curve slopes down. This is a person whose value for the good is their point on the line. If we push the price above market clearing, then we introduce two distortions. First one is this triangle right here. This is trade the market would like to do, but doesn't happen. It's called the deadweight loss triangle. These are places where there's people whose demand exceeds other people's cost of providing, and so we could effect trade. And then secondarily, there's this dotted line. It's not sort of as clear visually, but there's fewer people who want to buy at this price than want to sell. And that means that we have rationing. We don't necessarily get the most efficient sellers selling. And if instead we pick the market clearing price, we sort of avoid both of these distortions. We supply and demand meet exactly, so there's no rationing, and we get that full triangle. Okay, so that's the standard argument for market clearing pricing. But let me point to something that's always been in this picture. And indeed, like it was in this picture when I first saw this picture at Econ 101, but I never noticed until we started working on this agenda, which is this rectangle right here. So under market clearing pricing, that rectangle is buyer surplus, right? It goes to the buyers. But when we push the price up, right, everything below the price line is seller surplus. And so another thing the market does is effect a transfer from the buyers to the sellers through pricing. And if for some reason we had a really high welfare weight on the sellers, then that transfer, might be high enough in value from a social welfare perspective to overcome both of these inefficiencies, right? There's an allocative distortion, but a consequence of that distortion is that we effect a transfer. And you can imagine that there are markets where this is first order. I mentioned rideshare earlier. A fact of rideshare is that the buyers on average are much wealthier than the sellers, right? Buyers are people who are choosing this over, some alternate mode of transportation. They're often even on, sort of corporate budgets or something of the sort, but whatever the case, they can afford personal rapid transit. The sellers, meanwhile, this is gig labor. They're often doing it as, sort of a second or third source of income. But even if it's their primary income source, it's not a very high income source. And so by virtue of the size these agents are in the market, sort of we can infer that this transfer, is a transfer from people who are reasonably well off on average to people who might be in, higher need on the margin, especially if they're doing it as a third or fourth job. And so as a result, we can start to see an instance in which we might value that transfer. Footnote, by the way, another reason rideshare type markets are appealing for this is that, buyers are pretty price inelastic. So the curve doesn't quite look like these straight lines, right? That deadweight loss is probably pretty small. So if you were to bump up prices a little bit, you probably wouldn't change demand very much. Let me just do one more thought experiment of this same intuitive style, just to continue giving the sense that we might in fact want these sorts of market distortions. And I should say, these two thought experiments are both two-sided markets. Most of the talk today, we're going to be talking about a one-sided allocation problem because it's going to highlight sort of a lot of the key dynamics and make them sort of pop better. But as you'll see, sort of this thinking shapes, two-sided and one-sided allocation problems for more or less the same reason. So let's imagine now a frictionless buyer-seller market. We're in sort of the classical Chicago model. And imagine the sellers become systematically poorer than buyers. Now, the poorer the sellers are, the more willing they are to sell on the margin at any given price. That's because they need money more, right? So their rate of substitution changes. Now they really need money. So if the price goes, so the market takes advantage of this to lower the price a little bit so we can do more trade. But the poorer the sellers are, the more money the designer wants them to have on the margin, all else equal. So if I make the sellers poorer, irrespective of what's going on in this market or anywhere else, the designer wants them to have more money. And now these effects are in like completely different spaces, right? I don't mean to like sort of suggest that these are sort of living in the same space, but note that they're going in opposite directions, right? As the sellers become systematically poorer than buyers, the market price decreases. So sellers get less money when they sell. But the poorer they are, the designer wants them to have more money. So the designer, all else equal, wants them to have more money. At some point, these two effects cross, at which point competitive equilibrium pricing is not socially optimal, even sort of in a single price mechanism context. And so hopefully, if you take only one thing from this tutorial, it's this idea that the welfare weights we place on agents affect how we think about the transfers in the market. And like normally when we model efficiency, we're just thinking about allocative efficiency rather than allocative efficiency and equity. And at least in some contexts, and we'll detail many more of them, we might believe that equity component is also first order. And so when we're assessing welfare and thinking about what the optimal allocation rule is, we should actually account for those welfare weights as well. This is not a new idea at that level of generality in particular. And there's this sort of canonical theorem of economic theory, which is that every interesting idea is an echo of some idea. In fact, I would even claim further: every idea in economic theory, interesting or otherwise, is an echo of some idea from the golden ages of theory, and this is no different. So the argument, as I just described it, was more or less made by Weitzman in 1977 in an utterly beautiful and extremely readable paper. By the way, we have links to these papers that we're going to be citing, as well as sort of broader further reading sort of in this research space on the tutorial website, which is now available. Sorry, we didn't get it posted long in advance of the tutorial, but it's there now. And so in particular, if you want to go find Weitzman's paper, you can open the website. So Weitzman asks, just like, what's the trade-off? How should we think about market pricing versus rationing in a two-dimensional type model where agents have a value for the good and also a value for money, right? And that's sort of a simple way of modeling this idea of some agents being poorer than others. It's like their marginal value for $1 is higher than for some other agents. And so in general, the utility form is, if you buy the good at price P, you pay sort of in utils lambda P, possibly again with some scalars or constants in the story. You pay lambda P because that's how much the shadow value of that money is to you, and you gain epsilon. That's your value for the good that you bought. And so what Weitzman does in his paper is compare welfare under the sort of optimal rationing price versus the market clearing price, and the key dynamic is there's a trade-off between allocative efficiency and equity, right? So if an agent, at the social welfare level, and in an agent's own sort of optimization, there's a trade-off between the value for good and the value for money, right? And so if you have a really high value for the good, but also have a really high value for money, then you might represent a reasonably low willingness to pay, even though you have a high value for the good. Those with a high value for money, high lambda in this context, have less ability in some sense to pay at any given price, because for them, the shadow value of paying $1 is higher. And so in particular, just as in those thought experiments I described, here if I raise lambda, I raise an agent's value for money, they become less willing to buy at any given price. Just as I lower it, they become more willing to buy at a given price, holding epsilon, their value for the good, fixed. And so what Weitzman shows, and there's formalism to it, Mohammad will speak a little bit more about that in a moment, is that the price system has greater comparative effectiveness in sorting out the allocation when wants are more widely dispersed. So when it matters more who gets the good, there's more dispersion in the epsilons, or when society is relatively egalitarian in income distribution, or when lambdas have reasonably low dispersion, so willingness to pay really becomes a measurement of epsilon, right? Like willingness to pay convolves your value for the good and your value for money. When there's a huge amount of dispersion in lambda, ability to pay drives willingness to pay. When there's low dispersion in lambda, the value for the good more drives willingness to pay. And conversely, rationing is more effective as needs are more uniform, so there's less dispersion in epsilon, or There we go. As there is greater income inequality. Sorry, I was going to try and read the precise quote, but the gather pop-up was right in front of it. And so again, right, as there's more dispersion in lambda, then we can sort of trend more towards wanting to ration because willingness to pay is less of a signal of value. Weitzman also, by the way, sort of addressed this question of like, is this a thing you ever want to do as an economist, sort of from the perspective of economics, because you could always, just maximize the value of the market, tax and redistribute. And he argued then, sort of, well, there's always some corresponding way of combining the price system with a lump sum transfer that will make everyone better off or at least no worse. That's true in principle, but the necessary compensation is practically never paid, right? So we often don't actually do this sort of optimal, fully redistributive transfer for every allocation that occurs in the world. Moreover, and this is going to turn out to be a core motivation, there's a class of commodities whose just distribution is sometimes viewed as desirable and as a desirable end in itself, independent of how society may be allocating other resources, right? So we might have welfare weights that specifically want us to sort of ensure that people have access to something, or especially as we'll see, when people's willingness to pay is actually inversely correlated with their level of need. And so there are also sort of like markets where goods are essential or something of the sort, and in which we want to sort of ease access to those goods in general. Okay, so one very last thing, when can this work? And this will be sort of the theme throughout the entire talk. The key dynamic is going to be, as we said, the trade-off between the value for good and value for money in determining willingness to pay. So what's going to matter is how much we can infer an agent's level of need from their market behavior. And so, just to say up front, we're not going to be advocating redistributive allocation rules in every market context. In fact, in most market contexts, you're probably not going to want them. But here to give you a sense of like how this inferring level of need works, this is only going to work in certain markets. So if we see someone, two agents, A and B, and they're facing a question of, do you want to buy an important medical treatment? And A's willingness to pay is, $30,000 and B's is $5,000. At least if the treatment is sufficiently important, the inference is probably that B is cash poor. B might be in greater need, because here it's like there's low dispersion in the value. We infer there's probably dispersion in the value for money. But if what's going on is we're trying to figure out your willingness to pay for a bottle of milk, A's willingness to pay is B's is 50 cents, $3, B's is 50 cents. The inference is probably not that B is dramatically poorer than A, but rather that B probably just doesn't like milk, right? It's much more likely that this is about taste than about ability to pay. And so, and when we'll elucidate this in much more detail, but the extent to which we're going to be able to learn about the welfare weights we place on different agents is really going to depend on the specific structure of the market and what the determinants of demand and how much people's behavior reveals about inequality in that market. So in this medical treatment context, we are going to be able to infer something about people's level of need from their willingness to pay. For ordinary low cost goods like milk with sort of some dispersion in tastes, we're probably not. So medical treatment, that sort of example is going to work. Bottle of milk, that's a market where redistributive allocation is going to be essentially impossible because we don't learn from people's behavior how we want to redistribute. So as we go, our ability to do redistributive market design is going to depend on the context. And in particular, and again, we're going to see this sort of over and over again as the models get more and more general, the correlation between behavior and possibly other observables and whatever our welfare goals are. All right, and so with that, let me hand off to Mohammad, who is going to take us through sort of the first framework and illustration.
Okay, thanks, Scott. Can you see my slides? Someone?
Yes, but they're not full screen.
Oh. Are they now full screen, or you don't see them?
They're now invisible.
Okay. We didn't test the full screen before, despite the fact that we came very early. Anyways, I can probably continue like this. It's not ideal, but I only have one screen, so it's a little bit tricky for me to see. Great, thanks, Scott, for doing this amazing introduction. And Scott is always super nice in sharing, like the Shapley values. It's been a super joyful and full of learning to work with Scott and Piotr and everyone who is in this agenda. So what I'm going to do now is to continue the ideas that Scott introduced, but not from a mechanism design perspective. Piotr is going to do the mechanism design for you in the next part. I'm going to kind of provide a proof of concept and walk you through why price controls can be optimal and what is the optimal price control and under what conditions price controls can be optimal. And then we will do a full mechanism design approach to this problem in the next part. So this question of are prices the best way to allocate resources is a classic economic question. Scott told you about it. And economists have been thinking about this question for a long time, including Weitzman paper that we just heard. So what Weitzman does in his paper, I'm going to review it in 30 seconds for you, is that he says, hey, suppose I have X goods, say X public home housing, and there are N people who are potentially interested in having this house. And each individual, as Scott told you, has a need, the epsilon or V here, and a marginal value for cash, lambda. And then the question that Weitzman asks is actually super simple. He even does not have an objective function in a well-defined, like welfare sense. He just measures the distance of different allocation to some ideal allocation that he defines. And then he asks, hey, I can run market mechanism, don't intervene, don't do anything except market mechanism, or I can do a completely free random allocation. Of course, you can imagine like a myriad of mechanisms in between. You can have a price that is not exactly zero, but it's a below market clearing price, and so on and so forth. And then the answer that he provides, as we just saw, is that it all depends on the variance of the need versus the variance of the marginal value for cash. In the extreme case, if I know that everyone has more or less the same like utility or need for this object, but there is a huge variation in marginal value for cash in society, then market mechanism is going to be a like terrible way to allocate resources, because like the people who are willing to buy are people who can afford. They are not necessarily the people who have slightly or higher or lower value. And on the other extreme, if the society is completely egalitarian, everyone has the exact same lambda marginal value for cash, then market mechanism is amazing because it has this screening power to pick people who need the object the most. So that's Weitzman's idea. What I'm gonna do now is to take this question to like a different level, still not full mechanism design, but a different level, and ask a slightly more general question similar to Weitzman. And then Piotr is gonna tell you how we can do even more general than that. So here is my model. I'm gonna go slowly through this slide, and then we will make it. I will go faster after that. So suppose you have one indivisible good, okay, and then you have a unit mass of sellers of this good. Okay. One example that I love is, or I love in the sense that it clarifies the intuitions of what I'm gonna do, is the kidney market in Iran. It's a legal market for kidney. You have sellers of kidney who are typically poor people, but anyone can potentially sell. And suppose you have the government who wants to buy kidneys from these kidney sellers and then allocate them in a different mechanism, but we are not going to focus on that part. I'm going to focus on this buying from sellers part. Each agent, each seller in my market is characterized by two types, two features. One is their willingness to receive, the rate of substitution, how much you are willing to receive to sell your kidney. And the other parameter is the welfare weight of this agent. And this welfare weight has two interpretations. One of them is what Scott told you. It's the marginal value for cash, how much a planner likes to give $1 to this person. And presumably the welfare weight on me is much more than the welfare weight on Bill Gates, because like any reasonable designer probably prefers to give $1 to me than to Bill Gates. There is a second interpretation of this welfare weight that comes in this bullet point 4. If an agent with type R and lambda sells an object at price P, you come to the market and you sell your kidney at price P, the utility you get is going to be simply P minus R. I mean, welfare weight is irrelevant for you. You just care about your rate of substitution. You were willing to sell your kidney at a price $5,000 and now you sold it at a price $10,000. You get some surplus. But the contribution that you have to social welfare is going to be multiplied by this welfare weight. Okay, so this is a reduced form way to model the fact that the planner gets more utility, gets more like value from your utility than someone else's utility. Good. Now, I don't know if you guys can ask questions, by the way, but feel free to jump in and ask questions. So, so this is the meaning of welfare weight. Now, there is a distribution of rate of substitution in the society. So there's a distribution of R. I'm not going to define the distribution of lambda. And the reason is that we are not going to use it. Piotr will show you a claim or basically a proposition that in any incentive compatible mechanism, you can never elicit lambda and R, both of them. So it's in a way, it's without loss of generality to assume that you can only elicit the rate of substitution. That's the only thing that determines your behavior in the market. So I'm not going to define this distribution, but you could define it and it would be fine. Now, my designer wants to buy a quantity Q of kidneys from these sellers. Remember, I have a unit mass of sellers. I want to buy something less than unit mass potentially, or maybe equal to the unit mass. And I have a budget of R. Okay, that is as much I can spend to buy this. This R has a feature. The feature is that if I set the market clearing price for quantity Q, which is this G minus 1 of Q. Remember, G is the distribution of the rate of substitution. So G minus 1 of Q is the price at which exactly a Q fraction of agents are willing to sell. I can afford it. So if I set the market clearing price and pay everyone exactly the market clearing price to buy a quantity Q, I have enough money to do that. And if I spend less than that, than my budget, I'm going to redistribute whatever is left to all agents equally. So, as I said, I don't know if you can ask questions, but pause for a few seconds on this slide because this is the main model slides I'm going to cover. But the basic idea is pretty simple. You have a unit mass of sellers. You want to buy some fraction of objects from them. You have a specific budget. Market mechanism works, but potentially you can do something beyond market mechanism because you have these welfare weights. If all welfare weights were equal, so basically if all of them were 1, the market mechanism was going to be the optimal mechanism. But in this world, you potentially want to do something else. Let's see what else you can do. So I'm going to impose a bunch of assumptions on this model to make it simpler. The first one is that let's assume that the rate of substitution is uniformly distributed. for sellers, and then later I will introduce a model for buyers, so everyone has uniform distribution. In principle, an allocation mechanism, even in this simple model that I introduced, can be fairly complex, right? You come to the market, you want to sell your kidney. I extract your willingness to pay in an incentive-compatible way. And I can offer you a potentially infinite menu of prices and probabilities. I can say, hey, at this price, you can sell with probability 50%. At that price, you can sell with probability 80%. At this price, you can sell with probability 1, and so on and so forth. And this could be a function of your R, your rate of substitution. I'm going to impose a huge simplification, or at least a seemingly huge simplification, by assuming that the planner is restricted to using a single price mechanism. So the planner is going to say, hey, this is the price to all agents. This is the price. You can sell at this price if you like, and you don't have to sell if you don't like. That's it. Okay, this includes the market mechanism. I can set the market competitive equilibrium price, that G minus 1 of Q, and anyone whose value is less than that is going to sell. Anyone whose value is more than that is not going to sell. Now, because of this simplification, you can immediately see that I can only elicit rate of substitution. If your rate of substitution is below the price, you're going to sell. If it's above the price, you're not going to sell. And for the welfare weight, in order for me to solve my optimization problem, my welfare optimization problem as a designer, I have to estimate your welfare rate by observing your rate of substitution. So I observe that you are willing to sell your kidney at a price of $5,000. Someone else is willing to sell their kidney at a price of $100,000. From that, I estimate the welfare rate of you versus someone else, and potentially I'm going to give much higher welfare rate to you because you were willing to sell your kidney at a lower price. In fact, I'm going to assume that this function is decreasing, meaning that if you are willing to sell your kidney at a very low price, I'm going to give you a higher welfare rate compared to someone who is willing to sell this object at a very high price. Cool. So this is what we're going to do. I mean, this is the picture I borrowed from Scott's slides. This is the price quantity curve. I have the supply curve. Suppose it's uniformly distributed. The market equilibrium price is simply G minus 1 of Q. If I want to buy a quantity Q, I just set this price. Anyone whose value is below this price is going to sell, and I buy a quantity Q. I can potentially set a price higher than the market equilibrium. This is called price control, right? I can set a price that is higher than the market equilibrium price. And then the fraction of agents who are going to sell is going to be more than Q, in which case I have to ration them, right? Only a fraction. I want to buy a quantity Q. Now I have more people who want to sell, so each person is going to sell with some probability proportional to these two numbers, basically Q divided by G of that price that I've set. The question I'm going to ask is, what is the optimal PS? What is the optimal price control? Is it going to be exactly equal to the market equilibrium price? Or sometimes you want to actually distort the market, set a higher price, and ration. And Scott already told you, rationing has a lot of welfare costs. I mean, you have the deadweight loss, you have allocative inefficiency, and so on and so forth. So this is the question we're going to solve. Choose a price PS to maximize welfare of sellers while buying a quantity Q and not exceeding your budget. Good. And this is my translation of this question into math. I want to maximize this objective function, which I will tell you what it is, as if by choosing a price that is potentially more than the market equilibrium price. I will never choose a price less than that, because then I cannot buy a quantity Q. I will have less sellers than Q. So my only option is to choose a price that is above the market equilibrium price. Then agents are going to sell with this fraction, with this probability, because I have more sellers than what I want. Each seller is going to be chosen with probability Q over G of that price. And then what do I get? What is my objective function? for all agents who would sell, which is anyone who has the lowest willingness to receive, to sell, someone who is willing to sell their kidney at a price like $1, to this PS, which is the market price that I've set. Anyone whose value is below PS is going to sell. Now, for these people, I'm going to get their utility, which is PS minus R, times the welfare weight they have. And remember, this welfare weight now I have estimated. I've taken the expectation, the estimation of their welfare weight by observing their willingness to pay. So this is the first term. The welfare function of the planner includes the utility of the agents multiplied by the welfare weight, social welfare weight of the agent. And then there is the second term, which is kind of new here, which is telling me, hey, if you have a budget of R and you spend you pay price PS for each kidney that you buy, and you buy quantity Q of kidney, you might have some remaining budget left. You're gonna redistribute that as a lump sum transfer to all agents. And this big lambda S is simply the expected value of welfare weights. Okay, remember, another interpretation of welfare weight is the value of giving $1 to agents. Now, if I take it, the expected value of that, that's the value of giving lump sum transfer to the whole society. So my objective function has this shape. For anyone who sells, I get this utility with the rationing probability. And for the remaining budget, I'm going to distribute it as a lump sum transfer, and I get this part. So I'm going to refer to this G-1 of Q as the competitive price or the market equilibrium price, and anything more than that is going to lead to rationing. So that's my objective function, and I want to solve this optimization problem. Now, you should kind of trust me here that I'm going to solve this problem. It's not a really complicated optimization problem. And the result of solving this optimization problem is going to be this. Let me define one notion. I'm going to say that we have low inequality on the seller side. I only have sellers here. We have low inequality if the welfare weight that the planner puts on the poorest seller is no more than twice the average welfare weight in society. If the person who has the lowest willingness to receive, the poorest person who is going to sell their kidney, has a welfare weight that is not like huge, it's less than twice the average, I'm going to say we have low inequality. This is the case when you have a relatively egalitarian situation that the poorest person is not that poor relative to the average. I'm going to call this situation low inequality, and the reverse of it high inequality. And the main theorem of this part says when seller side inequality is low, then it is optimal to work basically to set the market clearing price and use the market mechanism to allocate the resource. This is kind of equivalent of Weitzman's result that when I have low dispersion in marginal value for money, I want to use the market mechanism. When the seller side inequality is high, then things change. Then there exists a quantity Q that if the total quantity that you want to buy, there exists a quantity Q bar, that if the total quantity that you want to buy is small enough, is less than that Q bar, then you want to actually set a price higher than the market equilibrium price. And otherwise, you want to go back to the market. Okay. So this is telling you that, hey, if inequality is low, market mechanism is great. If inequality is high, then there are conditions under which price control works. And let me give you an intuition of why that's the case. There are three effects when I have a price control. The first effect is that allocative efficiency is reduced. That one is what Scott also talked about. It's kind of the first order effect of having a price control. The second effect is that I will have less money to redistribute as a lump sum transfer. If I increase this price, the remaining budget would be lower. So that decreases my objective function. Both of these two are negative effects. I don't want to do price control if it was only for these two. The third effect is actually positive. Those sellers who sell are now getting more money. The question is when effect 3 is going to be more than 1 and 2. And if we look at the joint effect of 2 and 3, you will see something pretty interesting. So if I increase the price so that I get $1 away from the average agent, this is the bullet 2 is $1 that I'm giving to an average agent. If I increase the price, I'm now reducing how much I give to the average agent. I would lose the average welfare rate for that $1 in my objective function. But what I get is that now I'm giving that $1 to the sellers, those who sell, because I have increased the price. And remember that, and for that, I would get the average welfare rate of sellers. This is the average welfare rate of anyone whose rate of substitution is less than price. These are all the sellers. And this is positive. Why? Because my sellers are those people who are poorer. Those people who sell in this market have, on average, lower rate of substitution. These are people who are willing to sell their kidney at very low prices. I care more about them than the average person in society. So the net effect is positive between 2 and 3. The only thing I need in order for price control to be optimal is that this net effect compensates the allocative inefficiency, for which I need two conditions. One of them is that I need this term to be high. I need high inequality so that this is actually a substantial positive. And then I need this Q to be low so that the loss that I have for this lump sum transfer is relatively small. Okay, that's the basic intuition. Of course, you can do the math and see how things work in math, but that's the basic idea here, that if you have sufficiently high inequality and low volume of trade, price control can be optimal. Now let me quickly do the reverse of this problem. So the reverse of this problem is, instead of buying from sellers, you want to sell to buyers. Okay, this is kind of the Weitzman problem. I want to sell to buyers. I have a public housing, a supply of public housing, I want to sell to people. The model is exactly the same. The only differences are pointed out in red. Instead of sellers, I have buyers. Willingness to receive becomes willingness to pay. Agents still have two types. Utilities are exactly the same. If you buy at price P, your utility would be R minus P. R is your rate of substitution. And your contribution to social welfare would be multiplied by lambda. And the designer wants to sell a quantity Q, and the designer has a revenue goal. I want to raise a revenue R, and if I set the market equilibrium price, I can always do that. Now, I can potentially reduce the market equilibrium price. This is the problem I'm now solving. I quickly jumped from this slide, but it's fine because everything is here. I have a demand curve. These are my potential buyers. The market equilibrium price is going to be this G minus 1 of 1 minus Q this time. At this price, I will acquire a quantity of Q. If I reduce the price, if I have rent control, then I will have more people who want to buy than how much I want to actually, how much object I have to sell, which is Q. Now I have to do rationing. If I have 100 houses and there are like 200 people, each person is going to buy with probability 50%. Now I can solve the exact optimization problem. The form is exactly the same. You want to choose a price below the market equilibrium price. You want to have rent control. And you're asking what is the optimal price below the market equilibrium price. These terms are all exactly the same. I'm not going to go through them. That's very similar. And again, I have a market competitive price, and anything below than that is going to lead to rationing. So here is the kind of surprising result here. Regardless of the inequality, low or high, it's always optimal to set the market clearing price. Price control is never optimal in this simplified setting. Okay, now why this is happening? Let me give you a simple intuition for that. People who are willing to sell their kidneys in the space of all potential sellers, those who eventually come to sell at a given price, are the poorest of my market. Those are people who have the lowest willingness to receive. These are the people who really need money. So market selects for the poorest sellers. People who are willing to buy at any given price. In the space of buyers, they are the richest buyers, right? If I set a price of $1,000 for the rent of a house, anyone who can afford more than 1,000 or whose value is more than 1,000 is gonna buy. These are the richest of the buyers in the space of the buyers. So market selects in the set of all potential buyers for the richest of the buyers and poorest of the sellers. So this price control can help sellers by increasing the price. I can help sellers, but by decreasing the price, I'm just helping those richest of the buyers, which is not what I'm interested in doing in principle. So using a single price, you can never increase welfare by having a price control when you're selling objects to a bunch of potential buyers. Now, you can write down the same intuition that I had here. I'm not going to go through that. Slides are online. You can see that this getting $1 from the average person and sorry, and giving it to a buyer is actually net negative. So the sum of 2 and 3 is already negative without 1. So you don't want to do price control, because by price control, you're stealing money from the average person and giving it to the buyers who is richer than the average person. Now, before I end, let me quickly tell you something that sets the stage for Piotr, which is I was focusing on a very simplified space of mechanisms, namely choose one price. Suppose I expand this set a little bit and allow you to choose two prices, okay? A high price and a low price. Sellers can come to the market and sell at the low price with probability 1 and high price with probability lower than 1. Buyers can come to the market and sell at the high price with probability 1 and the low price with the probability less than 1. Okay, I just give you one more tool. You may not want to use it at all, but I'm giving you a tool. Hey, you can set a price, and on top of that, you can set another price. Then what's going to happen is that, sorry, something happened here. Then what's going to happen is that on the seller side, nothing will change. So it's going to be exactly the same as before. It's actually kind of surprising and interesting that you don't want to use these two prices. On the buyer side, however, now the result is going to be that if you write down the objective function, it's going to be exactly the same. You just have this probability lambda, probability delta of like rationing. Some buyers are going to choose the rationing option. These are the buyers who are going to buy at a low price with some probability. Some buyers are going to choose the sure option. They're going to buy at a high price with probability 1. And then you have some budget left for lump sum redistribution, and then you have market clearing and revenue like constraints. You have to buy a quantity Q, you have to sell a quantity Q, and you want to raise a revenue R. Then you can see that the theorem changes. Now that I allow buyers, I allow the designers to have two prices for buyers, the result is going to be that, again, if the inequality is low, you want to offer only the market equilibrium price. If the inequality is high, then there exists a quantity Q that if you are going to sell more than that quantity, if the volume of trade is high enough, then you want to do rationing. Rent control can be optimal. And otherwise, you don't want to do rationing, you want to set the market equilibrium. This is exactly very similar to the theorem I had for the sellers in the single price mechanism. And the reason this is happening, and I'm going to close with that, is that now my poor buyers are going to choose this rationing option. This is the option that my poor buyers are going to buy at a low price with some probability. And because of that, stealing $1 from average person in society by reducing the price, having rent control, and giving it to these buyers actually could be net positive. These are the buyers who are gonna buy at this rationing option. Uh, Basically, what's happening in a very like intuitive fashion, rich people are gonna go after the sure option because they don't care about money as much. They have very high rate of substitution, and then because rich people are gone, now I can help poor buyers by having rent control, a price P that is below the market equilibrium, and agents are gonna be rationing. Thank you. I think we can probably take a break, take questions, and then Piotr is gonna continue with a full-blown mechanism design approach to this problem.